Hello guys, good evening everyone and welcome back to 360DigiTMG's Domain Analytics program. Today is the 8th day and it is the last day of the Domain Analytics program. So far we have discussed about few algorithms and how can we use, we have taken the use case scenario as well. So what are the things that we have discussed? Let me quickly go through it, and if you haven't watched any one of those, in that case simply go to the transportation analytics and whichever the use case scenario that you haven't seen, you can simply go through and you can watch that video. So the very first day that we have discussed about the applications of machine learning algorithm. Very first day that we have discussed. Yeah, applications of a machine learning algorithm or machine learning techniques or AI when it comes to transportation. We have seen different examples where exactly we need improvement, and so how can AI and machine learning can play the vital role in order to improve those applications that we have seen. And the very first day I have taken different examples and the use cases. And the second day we have discussed about the CRISP-ML methodologies. What are the CRISP-ML methodologies? Where exactly we'll be using any data science project, irrespective of any domain. In the data science project, we will be applying the same CRISP-ML methodologies. So, what are the CRISP-ML methodologies? In those are the 6 phases we'll be having. Right? Hope you guys have an idea about that. So each phase, what exactly we are doing, what we are doing in the very first phase and second phase, third phase, something like that. We have discussed this very second day, and then we have discussed about the machine learning, data mining, machine learning. What are the different machine learning techniques we'll be having, like supervised and unsupervised. So what is the difference between them? And we have seen what are the pre-processing techniques we'll be having. Third day, we have seen what are the pre-processing techniques we'll be having for both structured data, what are the structured data as well as unstructured data. We have briefly discussed what exactly the different anomalies will be present when it comes to structured data. What are the anomalies are present when it comes to unstructured data that you have seen. And then on the fourth day, we have taken one use case scenario. We have taken one algorithm actually from unsupervised learning. From unsupervised learning, we have taken one algorithm, and we have that is what K-means. We have taken K-means algorithm, and we have taken one use case scenario, the real-time use case scenario, and we have applied the machine learning algorithm that we have done on day 4 actually, sorry. And then we have taken one supervised learning algorithm on day 5. That is what KNN. K nearest neighbor algorithm that you have taken. How the K nearest neighbor algorithm works? What is the logic behind it and mathematics behind it? So that we have seen, and we have taken one use case scenario as well when it comes to KNN, and we have applied the KNN algorithm and we have done the predictions. What we have done here, KNN mostly will be taking the distance. Based on distance, we are finding the similarity. And based on that, we are simply categorizing the that particular data points into different classes. That we have seen. And on 6th day, we have discussed about the decision tree algorithm. It is one of the most important algorithm when it comes to machine learning. Using this, we will be having some advanced decision based tree-based algorithm. Those are XC-boost, gradient boost. So powerful algorithms will be having. So what happens when it comes to decision tree? How a decision tree will be implemented, or the mathematics behind that particular decision tree algorithm that we have seen on 6th day, and we have taken the use case scenario and we have applied the decision tree algorithm. So that we have done on day 6. And yesterday, last class, we have discussed about the 7th day. Linear regression. These are the supervised, and we have discussed unsupervised, that is K-means here. Linear regression. So we have what exactly the linear regression, and what is the mathematics behind it. What is the formula for the linear regression? So what are how we will be implementing the linear regression that we have seen, and we have taken one use case scenario in order to apply the linear regression by machine learning algorithm. So these are the 7 days schedule that we have so far that we have learned. So today we will be discussing about neural networks. We'll be discussing about what exactly neural networks is, what is the difference when it comes to machine learning and neural networks, how neural networks or the deep learning comes to the rescue when machine learning is not performing well. That we will see, and we will be taking one use case scenario. Using that, we will be applying the multi-layer perceptron algorithm, and we'll do the prediction. So what is that use case scenario we'll be discussing at the end of the session. So these are the things that we have discussed in the last 7 days. If you haven't watched any one of those, in that case, simply go to 360DigiTMG channel, YouTube channel, and you can simply select that day and you can watch the transportation domain analytics program. So before getting into the session, we'll go through what exactly the agenda for this session. What exactly is the neural network in transportation analytics? So what are the neural network primer? What are the things we'll be considering when it comes to? And what is the perceptron and the multi-layer perceptron? What is the difference between both? And we will be using the activation function. What are the different activation functions we'll be having? And error surface. So when you're calculating the error, we'll be having 2 types of error. When you have just 2D plane, in that case, we can simply select, you can simply find out the error, whether it is maximum or minimum. Based on that only we will be deciding, right, what is the error for that. And if it is multiple input features you are using, in that case, what happens? We'll be saying to find out that we will be using what gradient descent algorithm, and what is that we will be discussing. So this is the agenda for today's session. Without wasting any time, let's quickly get into the session. Yeah. So where exactly we'll be using the artificial neural networks? What are the drawbacks when it comes to machine learning? Yeah, what is the drawbacks we'll be having when it comes to machine learning, and where exactly we'll be using the artificial neural? So when most of the time what happens compared to the machine learning algorithms, the neural networks will be giving the good accuracy. Then why do we need to use the machine learning algorithm? So what happens when you are using the machine learning algorithms, when you have a large amount of data, working with high dimensional data, when you have large amount of data, high dimensional data, in that case, machine learning doesn't perform well. To avoid that, we need to have an artificial neural network. So in artificial neural networks, we won't be doing much, and the rest will all be taken care of by the neural networks. So we did just a basic coding we'll be doing in the beginning, and then rest everything will be done by the artificial neural network. So whatever the things that are going inside the artificial neural networks are multiple layer perceptron, multi-layer perceptron. It is a complete black box techniques. Complete black box techniques. You won't be having any idea about it. That is the reason we'll be calling it as a black box techniques. Underline whatever the mathematics that are going into the neural networks, you won't be having an idea in that. That is the reason we'll be calling it as a artificial black box techniques. So what exactly the artificial neural networks? So it is a capability. The artificial intelligence is a capability of machine to imitate the human brain, human intelligence, you can simply say. So whatever the activities that our brain is doing, they can simply say it is the dendrites, what exactly the dendrites is doing. So it will simply take the inputs from different ways, and if whatever the data that we'll be having into that the cell, if it is reaching maxima, in that case, whatever the information we'll be having, it simply transfer. Whatever the information we'll be having, it will simply transfer into other neurons, or you can say other body parts of the human body. Similar to that, we will be having the neuron. So it will be taking the information from inputs similar to that. It is one structure, physical structure when it comes to artificial neural networks. Here we will be having the inputs similar to the dendrites. There will be having dendrites. It will be taking the input signals, and it will process the signal, and then it will do the transaction. It is just transfer from one form to one place to another. Similar to that, here we will be having the different input layers, X1, X2, and X3. It will take the inputs. What are the inputs that we are giving below? We will be calling those are the features, different features. It will simply take the features and it will process in hidden layers. It will process based on those, and it will give you the output. So similar to the dendrites, like how our neurons, human neurons, neural networks, brain neurons, brain will work. Similar to that, it will simply mimic. It won't be doing the exact, but we are trying to replicate that human brain processing into the neural network. That is the reason we will be calling it as artificial neural network. Yeah, so why we are using the neural networks when we have already machine learning that we have seen, right? Like when you have most number of dimensions and maximum data, huge data, in that case, machine learning algorithm will struggle to give the prediction. In that case, we will be using the neural networks. In that case, if we have neural networks that are working fine, even though you have a high dimensional data, then why do we need machine learning? That is pretty obvious question, right? So neural networks, like I've explained, it is a black box techniques. Whatever the thing that is happening inside that processing, we won't be having any idea. In that case, then only we'll be calling it as black box technique, right? So some algorithms, we need to have an explanation. We don't know what exactly it is doing. When it comes to machine learning algorithms, we'll be having an explanation for each and every algorithm. Let's say last 2-3 days we have seen a few algorithms like decision tree. We have seen linear regression that we have seen, and we have seen the KNN algorithm. So what happens in each and every algorithm, we have explainability. What exactly the explainability? Let's say when it comes to decision tree. So how it is deciding the class of that particular person. So it is classification, hence we'll be using decision tree. We can use both for classification as well as regression tree when I'm talking about the classification. Let's say I want to classify different into different categories. Let's say based on features. Let's say I have these are the features I'll be having. In that, what are the features I'll be having, whether that particular person has a COVID or not. This is my output, that is Y. And we have yes, no, yes, something like that. This is the output, whether that particular person has a COVID or not. Yes means that that particular person has a COVID. No means he doesn't have a COVID. So for that, we'll be taking some features, right? Like what could be the features to determine whether that particular person has a COVID or not. We'll be having cough, whether that particular person has a cough or not, or that particular person has a body pains or not, whether that particular person has a fever or not. And what else will be having? Taste, whether that particular, who are people who are who will be having the COVID. In that case, they will be losing the ability to taste and as well as smell. So we'll be taking that features as well. Based on that, we will be deciding whether that particular person has a COVID or not. So this is the based on this, we'll be taking the decision. When it comes to decision tree, it will simply tell you what are the features it is considered. We'll be having the tree something like this, right? So what are the features it is considering? How it is coming to that particular conclusion, saying that that particular person has a COVID. It will tell you each and everything, whatever the process it is happening inside the decision tree, we will be having an idea. So it will simply display. So, but when it comes to neural networks, you don't have any idea about that. Simply, so this is how you'll be having neural network summation. Whatever the things that are happening inside it, you have no idea. Here you can see. Here we are simply giving the same feature, whatever the feature I've just talked about, whether that particular person has a cough, cold. These are the features of the, that COVID, right? Fever. Like that, we'll be having multiple features, and we'll simply feeding to the artificial neural network. So based on those input that we have given, based on those, it will simply go through it, and what are the patterns will be having, it will simply go through the patterns. Based on that, it will give you the output. What features it is considering, which is for which it is giving the importance, all those information is not available. Those kind of information is not available at all in that case. So we need explanation, right? Sometimes we need explainability. What exactly reason? And let's say similar to this, we'll be having but bank. In this case, you don't need. Let's say this COVID case, we just need result. Why do we need to know what exactly it is considering and all? In that case, it's fine. When it comes to bank, whether that particular person has gonna default that particular loan or not, whether one person will default the loan or not. Let's say we are predicting just yes or no, whether that particular person is going to default or not. Based on that, we'll be deciding whether we should give a loan to that particular person or not. Right. So here we need explainability. Randomly, some person, if you use artificial neural networks here, we won't be having any explainability based. You'll be getting the accuracy, good accuracy. Let's say 98% accuracy got. It will simply say whether that particular person is going to default or not, but it won't give you any explanation. And if customer asks you, and you have rejected loan based on the artificial neural, and if they ask you, why did you reject my loan? What is the criteria I didn't meet? If we ask you in that case, our machine learning model rejected, that is the reason. I'm not giving you them. That is not a proper explanation at all. Some machine is saying that not to give a loan, that is where he didn't give a loan. We will be getting angry, right? So in order to avoid that, we need machine learning models similar to kind of decision. So that we need to have some rules. We have seen, right, on the decision tree when we are discussing the decision tree, how the rules are formed when it comes to decision tree. Wherever you have less rules, we'll be considering that as decision tree as the best. So that is the reason instead of AI, we will be going with machine learning model, even though AI is giving the better accuracy. We need an explainability. I hope you guys understood what is it. And here we'll be having 3 types of deep neural networks we'll be having. And it is a part of, it is a part of deep neural networks, or deep learning is also part of the machine learning. It's a small part of the machine learning. Neural network is a machine learning model inspired by the networks of the biological neuron found in our brain that we have discussed. What are the different deep neural networks we'll be having? The very first one will be having ANN, artificial neural networks. It is also called as multi-layer perceptron. I can also call it as multi-layer perceptron. And then we'll be having convolutional neural networks. That is also CNN. And then we have recurrent neural networks. So these are the 3 types of deep neural networks we'll be having. And here today we'll be discussing about the multi-layer perceptron. We'll be having the single layer perceptron as well, but here we'll be discussing about multi-layer perceptron. Fun fact, a human brain is made up of 85 billion neurons, resulting in a new capable of representing the tremendous amount of knowledge. That is the reason all the processes, while you are doing any work, in that case, just imagine how many neurons that are working in your mind. So we'll be having 85 billion neural networks. For instance, a cat has roughly 1 billion neurons. More number of neurons in that case, the capability to think or intelligence. In that case, it will be high. So cat has roughly 1 billion in that case. The capability of thinking is lower compared to the humans. And mouse has about 75 million neurons. Cockroach has only about 1 million neurons. In a contract, many ANN contain far fewer neurons, typically only several hundred. See, compared to this, so whenever you are using the machine learning model, machine learning models or AI models, so we are barely using like several hundred neurons. Compared to that, how superior is human brain? Just think about it. Compared to the neural network that we are using, we are in a no danger of normally what people think artificial intelligence might be create some disturbance when it comes to human environment, something like that will be fun, right? So we are simply using the very few several hundreds of neurons, so it is nowhere near to dominate the human brain, since we are not using that many neurons. So it is how many number of neurons we'll be using and how many number of neurons human brain will be having. So how neural perceptrons are the pre-processing of how perceptron algorithm will go. So it is the structure, is a structure of artificial neural network. So what happens here, whatever the input that we are giving, that we will be having something like we have discussed in the very first slide, right? How it will be, the input will be there. So each and every input will be having, right? Let's say similar to that only. Let's say you have 5 inputs. In that case, we'll be having 5 inputs, x1, x2, Inputs means here, these are features we are talking about. Previously, we have discussed about the COVID, right? Based on this feature, will be assigned, weight will be assigned. Weight will be assigned. It is W1, W2, W3, W4. And you'll be having the summation and this output, and then we'll be having the output. Here we'll be having the activation function. Whenever activation function is activated, in that case, it will shoot the output. When you have just two binary classification, whenever you have just binary classification, in that case, we'll be using this. The Perceptron algorithm is binary classification machine learning algorithm. Since we'll be having just two outputs, whether it is yes or no. That is the reason we'll be using for binary classification. The building block of neural networks contains what? Neurons will be having. These are the neurons which carry the input. And based on those inputs, we'll be having the weights. And for every neuron, we'll be having one bias. And we'll be having one activation function. It has a single node or a neuron that takes a row of data as an input and predict the class level. So here we'll be having different inputs. It will simply take the inputs, and based on those inputs, it will be predicting which class it belongs to. Neurons have weighted inputs, threshold values, activation function, and obviously these are the weighted outputs. It depends on the input. We'll be having the weighted input. So when it comes to output, how we'll be getting the output? Here we'll be having bias one, so the output will be predicted as beta naught, beta 1 x1, or you can simply say here W1 weight sense, and beta 2 x2, beta 3 x3, something like that. How many number of features will be having? That many will be having. So this is achieved by the calculating the weighted sum of the inputs and the bias. So we'll be calculating the input sum. That is what here we'll be having W1 and X1. In that case, W1 X1 plus W2 X2 plus W3 X3 plus bias will be having, that will be calling it as activation function. So whatever the output that we are getting here, it will be in the form of probability. It will be in the form of probability. When, let's say, we have given a cutoff which is equal to 0.6, 0.5. If the value is more than 0.5, in that case, this activation function will be activated and it will show the output. And if it is less than, in that case, it will simply show the 0. If it is active, in that case, it will be getting the 1 class, and if it is not, in that case, it will be getting the 0 class. So if the activation function is greater than, in that case, we'll be getting the 1. If it is equal to or less than, in that case, we'll be getting the 0. So this is how we will be getting the output when it comes to neuron. As the inputs and are multiplied by the model coefficient, what are the weights will be having, that will be characterized as coefficient. As in case of linear regression and logistic regression only. Okay. So when it comes to but linear regression, linear regression, here normalization and standardization, since where exactly we'll be using normalization and standardization, when you have huge scale gap, different scale, all the inputs that we are using, if they are in the different scales, in that case we'll be using normalization or standardization, right, in order to bring down everything into single scale, or to make scale free, or to bring down into the one scale, we will be using the standardization. This will decides like how kind of accuracy that you are getting. I mean, it will help to improve the help us to improve the accuracy of that particular. especially when it comes to linear and logistic regression that we have already known. So here you can see how the error, how do we change the output of the error. So let's say how that neural networks will learn the new terms. How can we change it? Let's say here we'll be having the similar structure, and we'll be having summation, and then we'll be having output. So let's say this is the input, and this is input 2, input 3, and input 4. And then we'll be having here summation, and then we have here one activation function, and we'll be having W1, that is weight, W2, W3, W4. So whenever you are doing some prediction, in that case, what happens? It will simply see whatever the actual value and the predicted value. Is it same? If it is not, in that case, it will find out the difference. That difference will be come back to the initial one, so that it will become the learning rate. So it is how can we find out the new term? We will be having the old weights. So we will be adjusting here in order to bring down the error term in our neural networks. What we will be doing, we'll simply change the weights. How these new weights will be changed now? First, we'll be calculating the that particular output, and we will be comparing with the previous one, and whatever the output difference will be having, we'll again feed into the old weights. That we will be calling it as back propagation. That will be calling it as back propagation. So what happens in the back propagation? Let's say how the new weights will be assigned. Randomly, initially, first what we will be doing, randomly we'll be assigning the weight. It is a vector, let's remember that. Randomly, first we will be randomly assigning the weight, and repeat until the error is less than the threshold or maximum iteration. And here we'll be giving the maximum iterations one. It's up to you. I mean, if it is reaching the minimum error point, in that case, it will automatically it should terminate that particular iteration. So here, what we'll be giving? Repeat until the error is less than the threshold. For each training, you'll be giving the X and Y value you'll be getting. So here we'll be, in order to how we are giving the new weights here. So here we'll be having new weight, and we'll be having the previous weight, and this is the learning weight. Whatever the learning it is done, and it is the error and that particular input. This new input will be given into this the same structure that we have. By changing the weights, you will be decreasing the error. Let's say the very first you will be having a line, and you can see right here here we are given weight is equal to 0.0,1. Here we will be having the misclassified case. In that case, we can simply apply this into the Wn plus 1, and then we'll be calculating the weight. And once it is calculated, now we will be drawing one more line using what? New weights. In that case, what happened? It is nearby, right? Previous compared to the previous one, it is nearby. Again, whatever the values will be having, weight values will be having, we'll simply input into those. In that case, we'll be getting the new. Like that, until and unless it will be correctly classified. Until and unless it is correctly classified, it will keep happening. Like that, we will be doing the classification. Okay, it is just we'll be having this is x1, and you can say it is x2, and it is x3, and it is w1, it is w2, it is w3, and we have a summation. It is activation function, and the output will be getting. So each and every time when you are giving the output, these weights will be assigned, right? Based on these weights, and we'll be calculating the error term. Whatever the error term we'll be having, it will come back to the weight and will change the weight. Each and every time we'll be changing the weight in order to decrease the error. Every time, each and every time it is learning rate. That is the we'll be calling it as learning rate. Like that, it will keep changing until and unless all the classes are correctly classified. So this is how we'll be doing the. Yeah, you can see neuron. This is a neuron. So we'll be having it is a neuron. Here we'll be having the inputs, whatever the features we are taking. These are the features, and we'll be having weights assigned to that particular feature, and we'll be having this mad function, and then we have activation function. Everybody shoots. In that case, we will be getting integration. You can simply say that the integration function or aggregated input sequence, and then we will be having the activation function threshold output. So this is your output. Whatever the output that we are getting, it is in the form of this I is equal to 1 into n wi xi plus b. Here b is the bias. B is, we'll be calling it as bias, and here we'll be having the weights, and here we'll be having the inputs, or you can simply call it as a feature. Yeah. So when you have just input, just one, you have binary. When you have binary output, in that case, it is fine. If you have, it should be whatever the output that you are getting. It will be a 0 or it will be 1. But when you want multi-class classification, in that case, multi-layer perceptron will be using as a supplement of feed-forward neural network. It consisting of 3 types of layer: input, output, and hidden layer. So when you have just single layer perceptron, in that case, it will be fine. You will be getting just 0 output or 1 output. When you want multiple output, in that case, we'll be going with multi-layer perceptron, MLP. Here we'll be having all the inputs. For that, we'll be having weights, and then we'll be having hidden layers. And then here we'll be having the output. That is, in that we will be having the activation function. Whichever the activation function is greater than that particular level, threshold level, in that case, that will be activated. Like that, we'll be having multi-layer perceptron. Here we will be getting the multiple output. The input layer receive the inputs and the signals to be processed. The required task, such as prediction and classification, is performed by the output layer. It is just to accept whatever the input that we are giving, and then it will be processed into the hidden layers. So whatever the process is happening inside the hidden layers, we won't be having any idea about it. So it is a kind of, it is black box technique. It is a black box technique. Number of hidden layers and that are placed in between input layer are the true computational engine of an. See, it is based on requirement, how many number of hidden layers you want. It is completely based on, it's up to you. It is your requirement. So these are the activation functions. We'll be having different activation function. Step function, we'll be having ramp function and sigmoid functions. Maximal when we are going with what binary classification, in that case we'll be using this step function, and ramp function will be having, and then sigmoid function when you have multiple outputs, in that case we'll be using that, and then we'll be having ReLU, and we'll be having the leak ReLU. These are the different activation functions we'll be having based on, see, the number of hidden layers you want to use, the number of hidden layers you want to use, or the number of activation functions you want to use, completely based on requirement, or it's up to you. Number of hidden layers you want, which activation functions you want, is up to you, and it is based on requirement. So one more thing here, we have issue. When it comes to neural networks, we'll be having so many features, right? It is multi-dimensional features we'll be having. In that case, it is important to find out the error term. What is the global minima? Here you can see when you are taking the values to the model randomly. So we'll be taking randomly, right? So let's say you are taking the values from here. Let's say from here you are taking. In that case, what it will do? It will decrease the whatever the error term will be having. It will reach to this value, and it will consider blindly. I mean, it will randomly take the input, so it will consider this only as a local maximum, local minima. And if it is here, in that case, it will consider this only local maximum, but it will consider it as a global minima, not a local minimum. But it is the global minimum? Not really. Here we'll be having a global minimum. At some point we'll be having a global minimum, but it is not considering that. So in that case, we have to do multiple iterations in order to get the minimum error and maximum accuracy. In that case, we'll be using the gradient descent algorithm to find out global minima and global maxima in order to decrease the error rate in the model and increase the accuracy of that particular model. So we'll be having here, you can simply see, when you have just two-dimensional data, gradient descent. Gradient descent is an iterative first-order optimization algorithm used to find the local minima and the maximum of the given function. So it is not, I mean, when you are taking random values, in that case, it will find out the global minimum. When you finding out the global minimum and global maximum, it is not possible. In that case, we have to do the multiple iteration. Then only we will be able to find out. When you have just two-dimensional, in that case, we can simply find out, right, what is the global minimum and what is the global maximum. That we can find out. When you have multi-dimensional data, in that case, we'll be using the gradient descent algorithm to find out. Here we'll be taking one use case scenario, that is what we are doing here. We are taking multiple features. What are the multiple features? What is the objective of this use case? We'll see. So here we'll be having different features of old car. Based on those features, we have to tell what could be the price of that particular vehicle. We have to predict the price of the particular vehicle based on the features it will be having. Based on feature, we have to predict the price. What are the features? We'll look into it. So it has over 1.5 GB file data, so it is not possible to run it directly, and try to simply show you how we can apply. So here I'm simply importing the data. Here I'm whatever the packages that I need, I'm simply importing. Then here you can see NumPy. You might be having an idea about NumPy, and pandas in order to do modification of our data, and simply apply the NumPy. I'm importing the, and for pre-processing, what are the things that I need? Label and encoding standard. I'm simply importing everything. Actually, I've worked on different algorithm. So I have imported that, but I'm simply using the multi-layer perceptron. Here you can see these are the features: make, condition, cylinder, fuel, transmission, drive, size, type, paint color. These are the different features we'll be having, and based on that, we have to predict whether what could be the price of that particular car or any vehicle. So these are the columns that are not necessary since I've web scraped the data, so that websites are also there. So I'm simply dropping that city, a city URL, make, title, status, since it is not giving any information to find out the, these are the information doesn't affect the price of that particular vehicle. So I'm simply dropping in all these features, and then we can see price year, I mean, in which year it has been manufactured. That is also plays a very important role, right? Which year model, and the manufacturer, who is the manufacturer, conditions, how many cylinders will be having, fuel, odometer, transmission, drive, type. So these are the features we'll be having. Manufacturer, who's the manufacturer, Lexus, Hyundai, and the condition, how is the condition of that particular vehicle, and cylinders, what kind of cylinders will be having, fuel, gas, odometer. So these are the features that definitely affect the price of that particular. So this is in the dollars, so I'm taking as it is. And whatever the features will be having, I'm simply converting into the price. I'm converting into the whatever the categorical features I will be having, I'm simply converting into numeric. So when you convert into the numeric, and here we'll be having good, excellent. These are ordinal data. It will be having order. So these also will be having ordinal delta. Whatever the ordinal encoding required, I'll be using that, and the rest I'll be using the automatic. That is one hard encode. So transmission, drive type, paint, and simply encoding those, and you can do this. Yeah, and simply finding out the correlation between all this feature. That is fine. And I'm simply applying the ADA, pandas profiling, check manual. Not to do, I mean, it's not possible to do manual, right? So I'm simply applying the, and we can do, it will take that, simply using pandas profile so that we can quickly go through ADA part. Yeah. So I'm directly going for MLP regressor. So what I'm giving here, hidden layers size, I'm giving it to range from 2 to 10, whichever it is giving the best. In that case, we'll take, and then I'm taking the activation as a ReLU, and solver I'm using the Adam, and learning rate I'm using the constant. These are the features I'll be using, and simply. Yeah. Yeah. So you just need to initialize whatever the parameter that you need, and simply given you can run it, and it will be giving you the prediction, like what will be the car range. And you can see right here what are the car price ranges will be having. Yeah. So it will simply give you the what could be the price of that particular product, that particular car, based on the feature that you have given. based on the feature that you are given, it will simply predict. Like these are in dollars, so it will simply print like $1,500 based on the features it has been given. Okay. Yeah, this is all about the MLP algorithm and multi-layer perceptron. Okay. So this is all about multi-layer perceptron algorithm. If you want, if you have like this a kind of transportation analytics in that case, yeah, if you want other videos or whatever the videos that we have taken from the first, if you want to watch those videos, in that case, you simply go to the 360DigiTMG channel and you can simply watch those transportation analytics series, transportation analytics and series. And if you want to kickstart your data science careers, in that case, you can simply go to YouTube and search Tame Python. Tame Python session by Freddy. You'll be getting the playlist of the Python. About 22 videos will be happening. These are very crucial when it comes to machine learning data science course. So we can simply go through it. And if you want to go through other domain analytics, in that case, you can simply search 360DigiTMG, 360DigiTMG YouTube channel. In that case, we'll be getting so many domain analytics programs that are going on. You can simply go through those videos. And yeah, this is all for today, guys. I hope you guys learned something from this video. And yeah, thank you for joining with us, and have a nice day. And we'll see you with one more domain analytics in next session. And until then, have a nice day and